अस्सलाम वालेकुम एवरीवन। क्या हाल है आप लोगों के? Okay, some interesting chat going on here. I tried this paper and got an A. Good for you. There isn't any difficult question in that paper except for question 11 part C. If you don't find anything difficult in this paper, then don't watch it. Simple as that. And lost 1 mark in explanation functions question in this paper. Okay. So honestly, I mean, if you've done this paper and you didn't find it difficult, then honestly, don't watch the stream. Watch some other stream. So I have physics P3 tomorrow. Should I be watching this or what? Depends on your preparation entirely. If you're well prepared for physics P3, P3 is what? P3 is practical, right? So do you really study for practical? You don't really study for practical, do you? I mean, I could be wrong. I don't remember. It's been a long time since I gave my exams. Good evening, sir. I had my paper in the morning. Sir, variant 13. Already lost more marks for sure. I wanted to get 100% in maths. Wait, are you talking about maths paper? Did you have your maths paper? I thought the other variant was on the 30th. Sergi functions are very difficult. I've done 2 streams on it. Okay, I've done 2 streams on it. So I would strongly encourage you guys to watch the 2 streams. I've covered a lot of past paper questions. I'll do another one also if needed. But make sure to watch that stream. P1 variant 13. Okay, that's interesting. Today was P13. Okay, so you guys are done with P1. Okay, that's brilliant. So how was it? Please tell us. Was it easy? Was it difficult? So we can, although there's no pattern, there's nothing we can say about paper 12, looking at paper 13. But I'd like to know how the paper was. I'm finding trigonometry hard. So trigonometry is a topic in which I'm supposed to do a stream on. I don't know if I will find the time to do it. Let's hope and pray that I do. So there is a pattern sometimes. Sometimes, yes. So not enough times for us to rely on it, basically. So I'm about to start, and before I do that, I'd really appreciate if you guys like the stream if you haven't done that yet, and also if you subscribe to the channel, that would be great. Sir, it was easy, but many found the circles question hard, and the last question, part A, and also the trig question was 6 marks, so they found it hard overall, mid. Okay, so let's hope the threshold is low enough for everyone to pass, inshallah. Everyone to get good grades of their choice. So what's your prediction for the most important topics? I don't have to predict most important topics really. It's kind of clear. The most important topics are calculus, trigonometry, functions, coordinate geometry. Yeah, so these are the most important topics. So I'll show you guys this one thing. I hope I can find it. Just a second. Just a minute, I'll show you guys something very important. So there's a whole analysis that I've done in which we can see the important topics, the percentage wise the topic distribution. I wanted to share it with you guys. Just a minute, don't go anywhere. Just a minute. Yeah. So basically, this is an analysis that my team has done for the papers 2020 to 2024. Okay. And you can see every topic, how many marks it carries and what's the weightage. Okay. So this is not by any means to tell you what topic you should skip. Okay, so please be advised, this is not by any means designed to tell you what topic you can skip, but you can see which topic is important and prioritize those topics accordingly. Okay, so basically functions, you can see functions is a topic along with differentiation that has been tested the most. Why? Because functions consist of multiple subtopics. You know, there's inverse, there is composite functions, there's transformation. So it's divided into multiple topics. So functions is a topic that's right at the top along with differentiation. So differentiation also makes up 15% of your paper. Then there is coordinate geometry. Now coordinate geometry makes up 10%, 13% of your paper. Acha, ye kaun hai jo itna cheekh raha hai, sir? Can you try doing this paper while explaining it a bit more than normally, please? Yeah, I will be explaining this paper in detail. Okay, so you can please stop spamming now. Okay, and then there is integration. So integration is also right up there. So I think these 4 topics, you can combine differentiation and integration and call it trigonometry. These 4 topics basically make up most of your paper. I think almost 30 and 30 and 25. So that's almost 50%, more than 50% of the paper basically. So, and then you have AP, GP, so that's AP and GP combined, that's 11%, then trigonometry. Now circular measure, quadratics, binomial theorem are basically the small topics that are there to kind of, you know, make the total equal to 75. That's it. Okay, so with that, let's start. I hope this helps to prioritize the topics. Okay, this by no means means that you can skip a certain topic or anything like that. So let's start. Okay, now all the questions, let's keep them relevant. Let's keep them related to what we are doing and not related to anything else. Okay. So the first question. Acha, before I start, let's have a look at the examiner report and let's also go over the threshold. So the examiner report of this paper is right here. The syllabus for this paper changed in 2019 and new topics including circles and transformation were introduced. Many candidates seemed very confident with these new topics, but others may have required further practice on them. The previous 3 reports have each highlighted that the question paper contains a statement in the rubric on the front cover that no marks will be given for unsupported answers from a calculator. Okay, so they've been very vocal about this over and over again, and probably because students are using a calculator and not showing the relevant working. Okay, Achha, I don't know if I mentioned this, please like the stream, I would really appreciate that, and also subscribe to the channel if you haven't done that yet. The message has been taken on board by most candidates, but there are still a significant minority for whom it has not. Clear working must always be shown to justify solutions. For quadratic equations, it would be necessary to show factorization, use of the quadratic formula, or completing square as stated in the syllabus. Using calculators to solve equations and writing down only the solution is not sufficient. It is also insufficient to quote only the formula. Candidates need to show the values substituted into it. Factors must also produce the coefficients of the quadratic when expanded. So I think that's kind of clear that we've gone over this multiple times. Now let's talk about this very specific paper. Many very good scripts were seen, although the paper was found to be challenging for candidates. Generally, candidates seemed to have sufficient time to finish the paper. Presentation of the work was mostly good, although some of the answers were initially written in pencil and then superimposed with ink, giving a very unclear image when the script is scanned. So please don't make sure that you do that you write your answer in pencil first and then thinking. First of all, you will not have enough time. That's problem number 1. Problem number 2 is that it's very difficult to read. Okay, so I think examiner को चक्कर ही आ जाएंगे पढ़ते पढ़ते अगर आप ये करेंगे तो. Candidates are strongly advised, centers are strongly advised that candidates should not be told to do this. Okay, now, so that was just a general overview. Now let's start. Now, when you're solving a past paper, please remember to take out some time to skim through the paper. I cannot emphasize on how important this is. Skim through the paper so that you know what topics you can attempt, what questions you can attempt easily, and what questions you are maybe likely to get stuck on so that you can leave them for the very end. So question number 1. So we're going to do that. We're going to take not more than 5 minutes to go through the paper. Question number 1, very easy. So we're going to do this immediately. Okay, we're going to do them as soon as we open the paper. You just have to integrate, find the equation of the curve. This is AS level. Okay, read the title bit of. This is AS level. Now this is binomial, which I think the most difficult questions of binomial are also fairly easy. This is quadratics. Once again, same goes for quadratics. Even the most difficult quadratic questions are also fairly easy. Question number 4, a standalone question on disguised quadratics, which is brilliant. 4th, easy marks. Find the area of the shaded region. So seemingly it seems like a very straightforward question. So I'm going to do this question immediately, as in I'm going to do this in the first round. Question number 6, circular measure. I don't know. I'm having doubts, so I don't want to waste a lot of time. I'm going to leave this for later. trigonometric identity can be, you know, it's a double-edged sword. Sometimes it's easy, sometimes it's difficult. So I'm definitely going to leave this for later, because trigonometric identity, you only know how difficult or easy it is once you start. So I'm going to leave this for later. Functions, definitely I'm going to leave this for later. I'm not going to touch it right now. ABGP seems kind of easy, so we might as well do it in the first round. Equation of circle could be easy, could be difficult, we don't know. And this, by the way, was actually a very difficult question. Then this is, we're given the equation of the curve, we have to differentiate. Seems like an easy question, we're going to do this. Find the x-coordinate of the stationary point in terms of k, also seems like an easy question. Given that k is equals to 10.5, so we'll see how difficult this question is when we get to it, okay? And that's it. So we've identified the easy questions. We're going to identify them to give ourselves a confidence boost. It's very important to feel confident while you're attempting the difficult questions, okay? So, question number 1. The equation of a curve is such that dy by dx is so and so for x is greater than 3. The curve passes through the point 4, 5. Find the equation of the curve. So we know very well that if you want to find out the equation of the curve, you integrate dy by dx. So first thing I'm going to do is I'm going to write dy by dx nicely. I'm going to write this as 4x minus 3, the whole thing raised to the power minus 3. Now we're going to integrate. We're going to integrate with respect to x. So when you integrate, you get y. 4 remains as it is. X minus 3, the whole thing raised to the power minus 3 plus 1, which is minus 2. Divide by the new power. And remember, whenever you integrate, there's a plus c that comes with the package. Okay? Divide by the new power, which is minus 2, sorry. Okay, now, so what do we have to do? We now have to plug in the values of the point through which the curve is passing, and then we're supposed to find out the value of c. So before that, here's my advice. My advice would be to simplify. Now, how would you simplify? Here's how you would simplify. 4 upon minus 2, that's minus 2. And let's shift this in the denominator. So x minus 3, the whole thing square plus c. Now we need a point through which the curve is passing. We're given that point, that's 4, 5. So let's plug in 5 in place of y. Let's plug in 4 in place of x. So 4 minus 3, what's that equal to? That's equal to 1 squared plus c. So 5 is equals to minus 2 plus c. That means c is equals to 7. So what's that? Y is equals to minus 2 over x minus 3, the whole thing square plus 7. Okay? So how would you rate this question on a scale of 1 to 10? How would you rate this question? I think this is probably 0 on 10. I'm talking about the difficulty level. Okay, so once you solve questions like these in the first round, I think I didn't mention how the scale works. 0 is like easy, 10 is like super difficult. Okay, so in that case, it's 0. All right, now let's move on to the next one. The coefficient of x power 4 in the expansion of so and so, and the coefficient of x square in the expansion of so and so is q. It is given that p plus q is equals to 76 or 276. Find the possible values of the constant a. Possible values, so there's no harm in thinking a few steps ahead. It's a good idea to think a few steps ahead, thinking that we're likely to end up with a quadratic equation. And that is why the question is asking us for 2 possible values. Okay, so think a few steps ahead always. Acha, what's that? I remember reading exam report where they said that if they got their whole question wrong, can cut it out and give reference. Yeah, of course you can do that. You can do that. If you get a question wrong, you can cut it out and you can solve it on the extra sheet that you're given. So the coefficient of x power 4. Now here the thing is, x is in the first term. Okay. So if x is in the first term, that means the question is what should be the value of r so that you get the power 4. So if you know the rules, that's great. If you don't know the rules, no need to lose your mind over it. Just do a bit of trial and error. Okay. So the rule is that if x is in the first term, the value of r is basically equal to n minus the required power of x. Okay, so you can always use your common sense. In binomial, that's the beauty of binomial. You can always use your common sense. So if you want x power 4 and n is 6, that means the value of r should be 6 minus 4, which means that the value of r must be equal to 2. Okay, so let's expand using 6c2. X raised to the power 6 minus 2, which is equal to 4, and then a raised to the power of 2. Okay, so let's work this out. 6c2, you can use your calculator. 6c2 I think is 15. So 15 x power 4, a square. Now what is the coefficient? The question wants the coefficient. So the coefficient is basically 15a square. Now who is this asking which year? I think you're the same person who doesn't read the instructions in the exam. So please nobody answer this person, let them figure it out themselves. Okay, now we have ax plus 3, the whole thing power 4, in which we want the coefficient of x square. Okay, so please nobody answer that question. Let them figure it out. So r is equals to n, which is 4 minus the required power of x, which is 2. And what's that equal to? That's equal to 2. Okay. So now 4c2, ax raised to the power 4 minus 2, which is 2, and 3 raised to the power 2. Now 4c2, what's that? 4c2 is 4 into 3. That's, okay, why am I doing this without a calculator? 4 times 3 divided by 2. So that's equal to 6. So 6 times a square x square into 9. What's that equal to? 6 times 9 is 54. So 54 a square x square, which means the final answer, the coefficient, not the final answer, but the coefficient is actually 54 a square. Okay. Now we want something to connect. Okay. When I said okay. Okay, I'm just going to stay quiet. So when we want something to connect the two, and that's basically this, p plus q is equals to 276. Now remember, according to the question, the coefficient of x power 4 in the first expansion was basically equal to p. So this is p. And the coefficient of x power 2 in the expansion of ax plus 3, the whole thing power 4, is q. Now what connects the two is basically this, p plus q is equals to 276. And it's all downhill from here. 15a square plus 54a square is equal to 276. Now 54 plus 15, that's 69a square is equals to 276. So 276 better be a multiple of 69. 276 divided by 69. Yep, thankfully it is. So a square is equals to 4. Remember the question said that we're supposed to find out the possible values. So a is equals to plus minus 2. That's it. Now quickly tell me your thoughts. What do you think about the difficulty level of this question? So by the way, I don't know if I shared the grade threshold of this paper. The grade threshold of this paper is insanely low. It's 49. Okay, 49 out of 75. Okay, so that is considerably low. So let's have a look at the examiner report. This question was also very well completed by most candidates. Full marks were often rewarded. The binomial expansion was generally very well understood, although the coefficient of x square was sometimes given as 54a rather than 54a square. Candidates were confident forming and solving the resulting equation, although the negative answer was sometimes lost. Okay, so don't think that the examiner report that you're reading is about, you know, some different kind of species. These were students like you, and you also have the same. You also have the potential to make the same kind of errors. Okay, so the whole purpose of reading the examiner report is to see what kind of errors students have made in the past and learn from them. Okay, and not repeat them, obviously. The threshold of a normal difficulty paper is somewhere around 55, 56, 57. That's how it is. Okay, so sometimes even 62. But these two were quite difficult, which is why the threshold is insanely low for these two. Acha, what's that? I got a graphical calculator. Can I take it with me? No, please don't do that. I mean, you can take a risk. You're very welcome to do that, but I advise you not to. Anyway, so we are supposed to bring this in completed square form. Now, there are many ways to bring a quadratic expression in a completed square form. You can choose whichever one you like. I'm going to go with the one we do in math. So we take 4 common from the first two terms. So that's going to be x squared minus 6x. So I'm going to leave a bit of space. And then I will write the plus p. Okay, so remember, we haven't taken out the p. We haven't taken out 4 common from p. Okay. Now, what do we add to bring it in completed square form? We add the square of 3 and we subtract the square of 3. Okay, so we're not doing minus 3 whole squared. We're basically subtracting the square of 3. Okay, so there is a difference between the two. Now, this part of the expression compresses and becomes x minus 3 the whole thing square. Minus 3 squared is minus 9. Don't forget that there is a 4 waiting outside and there is a p waiting on the other side. So we have 4 x minus 3 the whole thing square minus 36 plus p. That is basically the answer to this question. Okay, so thoughts on this? Acha, wait, we're not done. let's do this first and then I'll take your thoughts. So hence or otherwise, find the set of values of p for which the equation 4x square minus 24x plus p has no real roots. Okay, now notice that this is a 1 mark question. So please don't waste time using the quadratic formula, although you could do it. Okay, you could use the quadratic formula, but I would advise to honestly not waste your time. Okay, why? Because if you have already converted this into completing square form, then all you got to do is this. No real roots basically means that a quadratic curve does not intersect the x-axis. Okay, that's what it means. You could use the quadratic formula, but this means that a quadratic curve does not intersect the x-axis. Now, what is the turning point of the curve above? The turning point of the curve above will be 3 comma p minus 36. Okay, so I've just written it nicely. I've written like this, 4x minus 3 the whole thing square plus p minus 36. Okay, now if you want, this is a minimum curve. Okay, so what does a minimum curve look like? This is what it looks like. Now if you want a minimum curve to have no real roots, then where would you like it to turn? Would you like it to turn below the x-axis? No. Would you like the y-coordinate of the turning point to be negative? No. Would you like the y-coordinate of the turning point to be equal to 0? No. You would like the y-coordinate to be greater than 0. Okay, so we're solving it like a 1 mark question. You can solve it using the discriminant also, but let's see how it is if we solve it like a proper 1 mark question. So if this is the curve, okay, and this is its turning point, which is h comma k, where would you like this turning point to be? You wouldn't like this turning point to be below the x-axis. You wouldn't like this turning point to be on the x-axis, because in that case y is equal to 0. You would like this turning point to be above the x-axis, which means you would like the y-coordinate of the turning point to be greater than 0. Okay, so p minus 36 is greater than 0, which means p is greater than 36. Okay, so this is how you would solve this as a 1 mark question. You can also solve it like a regular discriminant related question, in which case you will get the same answer. Okay, so alternatively, if this, now this is basically something which honestly speaking, I don't think, okay, so I'll ask you guys honestly, you guys will answer this question better than me. Will this occur to you in the exam with the added exam pressure? You think this will occur to you in the exam? And you can be honest. You can be totally honest. Okay. So there you go. There you go, basically. Okay, so you got to have, it's okay. It's okay. You got to have you always have a plan B. Plan B is b squared minus 4ac is less than 0. So 24 squared, that's 576. 576 minus 16, p is less than 0. Now this isn't exactly lengthy. Okay, this isn't exactly lengthy either. So this means 576 is less than 16p, which means we divide both sides by 16. So that's 36. So 36 is less than p, which means p is greater than 36. So there's always an easy way out. I mean, the majority of the cases, there's a way out. Okay, there is a way out. But remember, I read this in the examiner report. Okay, I read this in the examiner report, and I want to share it with you guys, because there's no point in solving a past paper if you're not learning from it. And that was that it is advised that you draw a rough sketch. So I read this in some examiner report. I can't seem to recall which one it is. Similarly, nope, not here. But I'll tell you that a rough sketch always helps. Okay, maybe it's in some other variant. No, same comments. So a rough sketch always helps to give you a better perspective. Okay, now let's move on. So solve the equation 8x power 6 minus plus 256x cubed minus 27 is equal to 0. So what is this? This is a disguised quadratic. Okay, this is a disguised quadratic equation. So how can we solve this? You can solve this by middle term breaking, or you can do substitution also. I honestly don't prefer substitution in cases like these. I prefer substitution when the powers are in fraction, because then it's difficult to take common. In scenarios like these, it's always a good idea to just do it without substitution. So what are we looking for? We're looking for two numbers that when multiplied give us the product of 8 times minus 27. What's that equal to? That's equal to minus 216. And the sum is equal to 215. So it's kind of a no-brainer that it's going to be 216 minus 1. So 8x power 6 plus 216x cube minus x cube minus 27 equals to 0. You could use substitution, but I'm not doing it because in this case, it's a waste of time, honestly. So what can we take common? We can take 8. Can I take 8 common? Let's see if 216. Yeah, definitely I can take 8 common. So 8 along with x cube common. So we have x cube plus, what is 216 divided by 8? That's equal to 27. So here we will take minus 1 common, in which case we will have x cube plus 27 equals to 0. So that means 8x cube minus 1 into x cube plus 27 is equals to 0. So 8x cube is equals to 1, which means x cube is equals to 1 upon 8. Now tell me what's wrong here. X is equals to plus minus 1 upon 2, because the cube root of 8 is 2. So tell me what's wrong here. And here we have x cube is equals to minus 27. Can we take the cube root of a negative value? What do you think? Is it possible to take a cube root of a negative value? Acha, what's that? I'll answer some of your questions now. So every time I sit to do past papers, I find the whole paper very hard, even though in my mind I feel like I know the answers. Can we use quadratic? Yeah, you can use quadratic formula. Okay, so there's got to be some questions, Mahir, if I hope I'm pronouncing it correctly, that you can solve easily. Okay, so I would suggest start with those, get your confidence level high, and then look at the difficult questions. So basically, whenever you're taking the odd root, there's no plus minus. Okay, so that was the error there. Here x is equals to minus 3. Okay, and you can always take the cube root or any odd root of a negative value. Okay, so that's perfectly all right. If you think substitution is easier, go ahead. Okay, I only prefer substitution when we have fractional powers. Okay, but if you want to use substitution, go ahead. If you want to use substitution, then just make sure that you mention it clearly. So I'd like to show you guys the examiner report for this. Most candidates recognize the question as a quadratic in x cube and were able to solve it either directly or by using a suitable substitution. A small number of candidates attempted to use x as a substitution for x cube, so please don't use that because x is a variable that has already been used. Okay? And this often caused the confusion. To avoid this, candidates should be encouraged to use a different letter in this type of question. Some candidates found the correct answers for x cube, but then incorrectly disregarded the negative solution. Others found the cube root of 1 upon 8 to obtain plus minus 1 upon 2. So see, people have done this in the past, so that means I hope nobody repeats it in the future. The most common error, however, occurred through using a calculator to solve the quadratic rather than factorization or other similar method. As stated in the key messages, this should be discouraged. So don't just use a calculator to give the answer directly, but I do advise that you use a calculator to check your answer. Okay. So I've been having trouble with calculation, specifically in integration. Sometimes when I insert the range in the equation, I get the wrong answer. Later on, after recalculating, I get the right one. Okay, so just check as you go along. That's what I would say. Simple as that. How to avoid silly mistakes, and due to that, I have low confidence. Check as you go along. Okay, so nobody has a magic fix to silly mistakes. Check as you go along. And don't think that you will have time towards the end. Now, whatever it is that you can check using your calculator, do it using your calculator. Like, for example, this is a 4-mark question. I can check the answer of this using my calculator, and I will do that. I will do it to make sure that I'm doing it correctly. Here also, you can check your answer using your calculator. So wherever you can use your calculator to check your answer, make sure to use your calculator. Okay, that's how you avoid silly mistakes. You minimize silly mistakes, okay? Second way. What's the second way? Second way, okay, I'll do it. So let x cube be equal to a, or you can call it y, just not x, anything but x. So if x cube is equals to a, then x power 6 becomes a square. Okay, so that means this becomes 8a square plus 215a minus 27 equals to 0. Now the only difference is that when you solve this, you will not get the value of a, you will not get the value of x, you will actually get the value of a. So a is equals to 1 upon 8, okay, or a is equals to minus 27. And then don't forget that a is actually representing x cube, so don't forget to change it and then solve it to get the final answer. Question number 5. The diagram shows the curve with the equation so and so. The curve meets the x-axis at the point 0, 0 and 4, 0. Find the area of the shaded region. So I think that these questions are basically the calm before the storm. So I'm just imagining how students must have felt while doing this. So I think they must have been like, oh, the paper is very easy, till they reached question number 6 and question number 7 and question number 8 and question number 9, because these were some really difficult questions. But anyway, let's take advantage of what's easy. Sir, is it necessary to show middle term? Of course it is. Bilal, I would suggest you watch the start of the stream when I'm reading the examiner report. You will see. So there's something I've discussed about using a calculator. So yeah. Now let's integrate. So we will integrate the curve within the limits 0 and 4. So it's a pretty straightforward question. Okay. So 10x power half minus 5 upon 2, x raised to the power 3 upon 2. So this is what we're integrating within the limits 0 and 4 with respect to x. Okay. Okay, now let's add 1 to the power. So 10x raised to the power half plus 1, that's 3 upon 2. Divide by the new power, so that's also 3 upon 2. Minus 5 upon 2. X raised to the power 3 upon 2 plus 1, so that's 1.5 plus 1, which is 2.5. Okay, and that means the denominator now gets multiplied by the new power, which is 5 upon 2 as well. And since it's within limits, there will be no c. Now don't just start plugging in the limits. My advice to you would be that you first simplify. Okay, so first simplify before you do anything else. And please use your calculator. Okay, don't try to impress the examiner by doing it without using the calculator. TK, examiner doesn't know who you are. The examiner is not gonna reach out to you, giving you personalized comments on your paper. So just use your calculator. No need to do unnecessary mental math. So let's do 10 over 3 upon 2. So 10 over 3 upon 2, that's equal to 20 upon 3. So 20 upon 3, x raised to the power 3 upon 2. Okay, minus, so 5 divided by 2 into 5 upon 2. So that's equal to 1. So simply x raised to the power 5 upon 2. Okay, what are the limits that we're plugging in? We're plugging in 4 and 0. So we're plugging 4 and 0. Okay. So we only have to worry about, if you think about it, we only have to worry about plugging in 4 basically, because if you plug in 0, everything just becomes 0. So let's plug in 4. So that's 20 upon 3, 4 raised to the power 3 upon 2, minus 4 raised to the power 5 upon 2. So that's with the upper limit plugged in. When you plug in the lower limit, everything becomes 0. Okay. So once again, use your calculator. 20 upon 3, 4 raised to the power of 3 upon 2, minus 4 raised to the power of 5 upon 2. Acha, what's that? So the answer is 64 upon 3. Okay, 64 upon 3, which is basically 21.333. But I don't recommend that you write it in write it as a decimal. If anything is in fraction, it's best to leave it in fraction. So that's it, 4 easy marks. Okay, now here's something that you guys should know. I hope you know by now because I've done it multiple times. I've done it in pretty much every stream that I've done related to integration. That is, you can use your calculator. You have this key to check your answer. And those of you who are worried about making silly errors, so this is for you guys. So 10x raised to the power 1 upon 2. Okay, remember, you don't have to write down the integrated equation. Okay, you don't have to write down the integrated equation. You have to write down the actual equation of the curve. That's the beauty of it. Your calculator will integrate it for you. Your calculator will plug in the limits for you. You don't have to worry about that. So 10x power half minus x, sorry, not x, 5 upon 2 x raised to the power 3 upon 2. Okay, ye hum, when will we use this? We'll use this once we're done, and now we just want to check the answer. So how did I write x? Now your calculator may have a dedicated key for x. If it doesn't, then just use one of these keys, alpha and x. Okay, now the limits are 0 and 4. We should have written that in the beginning, 0 and 4. Press the equals to sign, wait for the magic. Okay, calculator hi hang ho gaya. Okay, this pretty sure this won't happen in a physical calculator. So yeah, there you go, 64 upon 3. Okay, so 64 upon 3 is what we got. 64 upon 3 is the answer. Now imagine you're doing this in the exam. You know for sure that you've done this question correctly, and you know for sure that you've done this question correctly. Is there any other question that you can know for sure? No. So how confident would you feel? You'd feel really confident, right? And then you'd attempt a question like this. My calculator isn't showing the answer? What do you mean it's not showing the answer? And please stop typing in caps. It seems as if you're shouting. Calculator hang ho gaya. Achha, okay, just wait. Okay. Just wait. ठीक है, अभी सही अभी आ जाएगा answer. Okay, just wait for a few seconds. आ जाएगा answer. Nothing to worry about it. It's a difficult question. It took us 5 minutes. If the calculator takes like 60 seconds, that's not a problem. अच्छा, अभी एक और कार्टून आ गया. What about working? बेटा मैं 10 दफ़ा बता चुका हूँ, हम कैलकुलेटर यूज़ करते हैं just to check our answer. Okay? So I think you've just joined us. मैं पहले बहुत दफ़ा बता चुका हूँ that we use our calculator to just check our answer. Answer नहीं आ रहा, ऐसा कैसे हो सकता है? मेरे calculator में आ गया. So let me use my physical calculator and see if we're getting the answer or not. 10x raised to the power half minus 5 upon 2. Okay, I think this was a bad idea. Raised to the power 3 upon 2 within the limit 0 and 4. Okay, mera bhi hang hua hai, just so you guys know. Here, you can see it. Okay, still waiting. Still waiting. Still waiting. Just don't press anything. Okay. Okay. Khair. I'm just gonna keep it on the side. Jaise answer aayega, I'll let you guys know. ठीक है? Here, see for yourself. No, I don't advise. देखो, I don't advise that you do it towards the end. ठीक है? Why? Because अगर आपने end में किया, it's best that you check as you go along. Simple as that. Because there's no guarantee whether you'll have time in the end or not. अच्छा, अभी तक I'm waiting. No answer. ठीक है? Do I take online classes? Yes, I do take online classes, but I hope you don't have your exam in May, June 2025. If that's the case, there's no point in joining now. Anyway, I still haven't gotten the answer. It's still waiting. So, जब आएगा, I'll let you guys know. अच्छा, अभी time नहीं ज़ाया करते. Let's start the next question. The diagram shows a sector OAB of a circle with center O. Angle AOB is theta radians and OP is equals to AP, which is equal to X. Show that the arc length AB, okay, आगे answer. आगे answer 64 upon 3. There you go. Okay. Here you can see 64 upon 3 in the calculator. Show that the arc length of AB is 2x theta cos theta. Now, ये जो सवाल है ना, ये काफ़ी मुश्किल सवाल है. ठीक है, मुश्किल not in the sense that once you realize how it's supposed to be done, it's easy. But for as long as you don't realize, it's a nightmare. Okay, and it's possible that you may start this question, do it a certain way, and then later on realize that it's supposed to be done some other way. Okay? अच्छा, मैं आपको बताता हूँ how you can minimize that. I'm not saying you can completely avoid that, but how you can minimize that. So we're supposed to show that the arc length AB is 2x cos theta. Now what's the arc length equal to? Arc length is equals to r theta. Okay, so arc length S is equals to r theta. Let's start with that. Now what do we have? We don't have r, we don't have theta. Theta to chalo hai, we're supposed to leave it as it is, but we don't have r. So that means now the search for r starts. Now first of all, realize that this is an isosceles triangle. Okay? So if this is an isosceles triangle, that means this is theta. And this would be equal to 180 minus 2 theta. Now you may be tempted to use cosine rule. Okay, you may be tempted to use cosine rule. Why? Because cosine rule is applied in a situation where you have two sides and an included angle. But do not use cosine rule. Up the thing is, how will we know that we don't have to use cosine rule? Here's how we know. When you have to use cosine rule, you will have cos of 180 minus 2 theta. Okay? And here we have cos theta. Okay, so you have cos of 180 minus 2 theta with the angle, and here in the answer we're supposed to have cos 2 theta. So that means we're not going to use cosine rule. So we're probably going to do something else. Okay, so let's get rid of this. Let's try something else. So how about, since it's an isosceles triangle, that means I can always draw a perpendicular and cut the base into 2. Okay, divide the base into 2. Remember, this only happens if you have an isosceles triangle or if you have an equilateral triangle. Okay. So this is a perpendicular line. So that means this is 90 degrees. 90 degrees or pi upon 2. It's up to you how you write it. But what we want is the radius. Acha, what's the radius? This is the radius. Okay, now if this is the radius, that means this would be half r and this would also be half r. Yeah, I know it's in radians. तो मैंने कब मना किया कि बेटा radians? अभी मैंने कुछ किया ही क्या है? What have I done anything that has to do with radian or degree? Okay, so if we use this triangle, okay, if we use this triangle, and it's always a good idea to draw the triangle on the side. Okay, I always recommend that. I recommend it, something I recommend in O levels, A levels, that it's always a good idea to draw the triangle on the side. Now this is half r. Okay, and remember, we're basically after r. Okay, and this is theta, this is x, and this we don't care actually. Okay, so इसको मैं m कह देता हूँ. So this is p, this is m, this is o. So what can I use that will give me r in terms of x? Cos. Why? Because we have the adjacent side, we have the hypotenuse side, so I can use cos. So cos theta is equals to adjacent, which is half r divided by x. Now remember, what do we want? We want x. So let's cross multiply. Oh, sorry, we want r. So that's x cos theta, which is equal to half r. Now let's cross multiply again. So r is basically equal to 2x cos theta. Now what's s is equal to? S is equals to r theta. So that means 2x cos theta multiplied by theta. So this can be written as 2x theta times cos theta. That's the answer. Okay. Now it's definitely a difficult question. I hope you guys have understood it. I'll give you guys a quick recap. So we don't use cosine rule. Why do we not use cosine rule? Because if we use cosine rule, we will have to deal with this angle, which will be equal to 180 minus 2 theta. Okay. And 180 minus 2 theta is nowhere to be seen. So that's why we don't use cosine rule. Okay. Now, we're not using cosine rule. That means we now have to think. So remember, we're dealing with an isosceles triangle. So we can always divide it into two 90-degree triangles and then work it out. Let's read the examiner report and see what the examiner report has to say. This question was the point where the paper started to be more challenging for many candidates. So that's exactly what we said. Okay, abhi tak to it was all fun and games. Now, things have gotten challenging. Achha, in part A, many used the sine or cosine rule correctly, but some were then unable to find the given expression. Angle OPA was sometimes stated to be theta or 2 pi minus 2 theta rather than pi minus 2 theta. For those who used angle OAP with cosine rule were usually more successful in finding the given answer, although possibly the easiest method was to split the triangle in half and use the resulting right angle triangle. Achha, let me tell you, those who used cosine rule were only successful because they were probably P3 students. Okay? Because in this case, you have to use an identity which is done in P3, a double angle identity which is done in P3. Okay? It's not done in AS, it's done in P3. So that's why I don't advise you to use cosine rule here. Okay, now let's resume. Any questions? Sir, how many marks according to you should an A student get on this paper? Well, if you want an A, it's quite clear that you have to get 49 above. Simple as that. When will you take ASP1 online mock? Inshallah, tomorrow. Tomorrow there will be an online mock for AS. I will announce it most likely tonight or in the evening. So tomorrow there will be an online mock for AS. Achha, find the area of the shaded region APB in terms of x and theta. So APB in terms of x and theta. Okay, so let's plan the answer. Area of shaded region would be equal to area of sector minus area of triangle. Okay. Now, as far as area of sector is concerned, area of sector is equals to half r square theta. Now, or we can use half rs. So we have all the options. Half times r times s. And I think I'm going to go with half rs because we already have r in terms of, or maybe we can use r square theta only. Okay, so it's up to you. You'll get the same answer irrespective. So I'm going to go with half r square theta minus the area of triangle, for which we can use sine rule. Okay, so for area of triangle, I can use sine rule, or I can use, let's use sine rule. Okay, so we have this length, and we have the angle in between. Okay, so that means half times r times x times sine theta. Okay, yeah, you can find out height also. That's why I thought about it, but let's not find out something that, let's use something that we already have. So half into r square, so r square would be 2x cos theta squared times theta. Okay, so that's half r square theta minus half into what's r? R is 2x cos theta. Okay, right here, here's r into x into sine theta. So are we supposed to write it a certain way? No, we're not supposed to write it a certain way. We're just supposed to give the answer in terms of x and theta. So we can then leave it as it is. So this would be 4x squared theta cos square theta, okay, upon 2, which we'll simplify in the next step. Here we can simply cross this out. So this would be x square cos theta sine theta. Okay. Now, let's simplify this. So this will become 2x squared theta cos square theta minus x square cos theta sine theta. Okay. Or you could have also used, because the question hasn't specified, so we could have also used x times sine of pi minus 2 theta. Okay, you could have used that also. So some questions say write your answer in third form. So the questions that will say write your answer in third form will probably have some values with the angle like sine 30, sine 60, cos 60. So you evaluate that and you give your answer in third form. It's as simple as that. Okay, so this is the answer and that's it, job done. If you want, you can take cos theta common, but only if you want. X squared with cos theta common, but if you don't, that's perfectly all right. Okay. Now, sirs, any other questions? So I got an A on this paper, but a C on February, March 2023. I've been getting A's. If you got an A on this paper, then February, March 2023 was not that difficult. I remember February, March 2023, that was not that difficult. Third form is this, root 2 or root 3. Whenever you have a square root and a non-perfect square, that's basically third form. Okay, now we are basically entering into some very hostile territory, although we've already entered it, okay? But now it's just going to get even more hostile, okay? So be prepared. It says by first expanding cos theta plus sine theta, the whole thing square, find the 3 solutions of the equation. Okay, so remember 3 solutions. Now I'll tell you, this is not a question for lazy students. Okay, so students who are lazy, students who are just looking for easy ways out, bad news for you. This is not a, students who are highly dependent on formulas, bad news for you guys. You're going to get this question wrong. Okay, there are no 2 ways about it. So this would be cos square theta plus 2 cos theta sine theta. Okay, so I think you guys are unnecessarily honest. Plus sine square theta is equals to 1. Okay, now what's cos square theta plus sine square theta equal to? That's equal to that's equal to 1. So we have, what do we have? We have 1 plus 2 cos theta sine theta is equals to 1, which means 2 cos theta sine theta is equals to 0. Okay. Now, let's get rid of this 2. If I take it across, 0 gets divided by 2. So that means ultimately it boils down to cos theta sine theta is equals to 0, which means that cos theta is equals to 0 or sine theta is equals to 0. So here is the approach that, sorry, not 2, 0. Here's the lazy student approach. Okay. Here is the students who are looking for formulas, looking for tricks all the time. So this is for you guys. First of all, make sure that your calculator is in radian mode. I'm sure everyone will manage that. Okay. So a lazy student would do this. Cos inverse of 0, get the answer 1 upon 2 pi. Okay. And here, they would take sine inverse of 0, get the answer 0. Now, where is the third solution that the question is talking about? The question is saying that find the 3 solutions. Oh, my approach is being show. I shall focus on your 1 pi upon 2. The question is, where will it come from? From sine graph. That's correct. Okay. So remember, whenever in the cases of sine and cos, if it's equal to 0, 1, minus 1, don't expect your calculator to help you. Okay, so if sine x is equal to 0, 1 or minus 1, your calculator is not enough to solve that equation, to find the value of x for that. If cos x is equals to 0, 1, minus 1, your calculator will not give you all the answers. However, if tan is equal to 1, then you can use the ASTC method, work it out. But if tan x equals to 0, your calculator is not going to help you. You have to refer to the shape of the graph. Okay, so this is the lazy approach. Now we will refer to the graph. So cos x is equals to 0. That means we're looking for all the values of theta when it's equal to 0. That's it. That's what we're looking for. So we're looking for all the values of theta when cos is equal to 0. So let's quickly make a rough sketch. Okay, and it has to be a rough sketch. It doesn't have to be pinpoint accurate. So here's the thing. This is 0, this is pi upon 2, this is pi, this is 3 upon 2 pi, and this is 2 pi. So when is cos theta equals to 0? Question for you guys. Cos theta is equals to 0 at pi upon 2. Okay. And cos theta is equal to 0 at 3 upon 2 pi. Okay. Now we already have the solution pi upon 2 and 3 upon 2 pi will be outside of the range. Okay. So 3 upon 2 pi will be outside of the range. So even if we write this for a minute, we'll have to ignore it because it's outside the range. Okay. But what if the range was till 2 pi? Even then you have to use this method. Okay. But because the range is till pi, we will write this, but we'll later on ignore it. Now we want all the values of theta when sine is equal to 0. So what do? We quickly make the graph of sine. Okay. And we see when is the graph of sine equal to 0. We know that it's equal to 0. We've already considered that. And we know that it's equal to 0 at pi and it's equal to 0 at 2 pi. Okay, so one solution is 0, the other is pi, and the third is 2 pi. Now, which one are we going to keep? We're going to keep 0 and pi. We're going to ignore 2 pi because it's outside the range. Okay. So here's the thing. You cannot use the usual way of solving a quadratic or solving a trigonometric equation over here because the quadrants are basically to tell you which trigonometric function is positive. Now here, what are you going to do? Cos theta is 0. In which quadrant are you going to consider it? Are you going to consider it in the first quadrant, in the second, in the fourth quadrant? Because it's not positive. It's not positive, it's not negative. So that's why ASTC will not work, your calculator will not work. What will work is common sense. Okay, so you have to use your common sense. So cos theta equals to 0. Your calculator only gives you half pi, it doesn't give you 3 upon 2 pi. Although here you get away with it because 3 upon 2 pi is outside the range. But at sine theta equals to 0, when is sine theta equals to 0? Sine theta is equals to 0, at pi, and at 2 pi. Our range is from 0 to pi, so that's why we ignore 2 pi. Okay, but if we don't use the graph, then we would get away. We will lose a solution and we'll lose marks. Okay, so remember, long story short, I'll write it down. Long story short. if sine theta is equals to 0 or plus minus 1. Use graph for all solutions. Okay. If cos theta is equals to 0 or plus minus 1, once again, use graph for the values of theta. And for the case of tan, only when it's equal to 0, that is when you should use graph. Okay. So what are ASDC they are talking about? I hope you're joking. Nothing. Now is not the time to explain, but I really hope you're joking. Anyway, hence verify that the only solutions of the equation are cos theta plus sine theta is equals to 1 for 0 to pi. Now, before I do that, let's read the examiner report. So, part B was generally well completed and part A, part 1 reasonably well, but the other two parts proved to be more challenging. In part A1, most candidates followed the instruction to expand through the resulting 2 sine theta cos theta terms. Sometimes was, although the resulting 2 sine theta, okay, so students are in A levels and what error are they making? They're forgetting 2AB. They're forgetting how to use the first identity, first or second. Okay, so that's one error. But it gets even worse. Good responses showed a simplification of the resulting equation to 2 sine theta cos theta equals to 0 and then stated that either sine theta equals to 0 or cos theta equals to 0. Sometimes only 2 answers were given rather than 3 asked for in the question. A minority seemed to be expecting the question to be more complex than it actually was. Similarly, part 2, okay, so we'll get to part 2. We'll see what part 2 says, but there you go. A lot of candidates did not realize that there's a third answer as well. Sir Zain said that whenever sine is 0, just write 0, don't solve it. I'm pretty sure he didn't say that. Okay, so whenever sine theta is equals to 0, there are 3 possible values when it can be 0. One is 0, the other is pi, the other is 2 pi. So I'm pretty sure he didn't say that. He probably said something else. Okay. Hence verify that the only solutions of the equation is cos theta plus sine theta equals to 1. Okay, so what are we going to do? We're just going to plug in. Achha beta, no need to spam. I would appreciate that. Okay, so now, so how will we verify the solution? We'll verify the solution by simply plugging in the values back into the equation. Simple as that. So we'll plug in theta as 0. Okay, so that means cos 0 plus sine 0 is equal to 1. So 1 plus 0 is equals to 1. That's correct. Okay. Now, then let's use the other value of theta, which is half pi. So that means cos of half pi plus sine of half pi is equals to 1. So that means 0 plus 1 is equals to, sorry, not equals to 0, equals to 1. So far so good. 1 is equals to 1. This is also correct. But what about the other solution, which is pi? So let's plug in pi and see if this holds up or not. So cos pi plus sine pi, is this equal to 1? So cos pi is minus 1. Sine pi we just saw is equal to 0. So minus 1 plus 0, is this equal to 1? Nope, it's not. So minus 1 is not equal to 1. So that means the only 2 valid solutions are 0 and half pi. Okay. Okay, so why is your tick mark a reflection? Okay, I'm a left-handed, so naturally I make inverted ticks. Achha, what's that? Take theta. So, okay, now remember, don't just take theta as 0 and pi upon 2 and leave it there. You have to verify that these are the only 2 solutions. So you have to show that the third is not a valid solution. Okay, so you have to show that the third is not a valid solution. Okay, so I repeat, if theta is equals to 0, you plug in 0 and show that it's a valid solution. If theta is equals to 1 upon 2 pi, you plug it in, show that it's a valid solution. So if theta is equals to pi, when you plug in pi, you show that it's not a valid solution. Okay, it is not a valid solution. And how do you show that? You show that by getting a different value on the left hand side, different value on the right hand side. Okay? Okay, now part B, prove the identity. So how do you prove the identity? Simple. In the denominator, you have what? In the denominator, you will have to multiply the 2. So when you do that, it will be cos square theta minus sine square theta. No, I'm not doing any paper prediction. Okay, it's a total waste of time. Now let's multiply this by cos theta minus sine theta. So what's that equal to? That's equal to sine theta cos theta minus sine square theta. Okay, here I would advise you guys to be a little careful, and especially whenever you have multiple terms to multiply. And this, by the way, will be multiplied by cos theta plus sine theta. So cos theta plus sine theta. Okay, now let's simplify. So we have sine theta cos theta minus sine square theta. Now 1 into cos theta, that's cos theta plus. And then 1 into sine theta, that's plus sine theta. Okay. Then minus cos square theta minus cos theta sine theta. And don't forget, here you can be a few steps ahead. How? Here's how. Look at the denominator here and look at the denominator that we have. Okay, so compare this with this. So we can see, I think anyone can tell that we're supposed to get it in terms of sine. Okay, so I'm going to start doing that. I will rewrite cos square theta as 1 minus sine square theta. Okay, so you don't have to be super genius to figure that out. I think anyone can figure this out, that our denominator must be in terms of sine, so we have to change cos in terms of sine. So 1 minus sine square theta minus sine square theta. Okay, so yeah, tomorrow, inshallah, you guys will have a live mock. I will announce it on my Instagram very soon. In fact, let me see what the status is. Okay, इसको simplify करते हैं. Just a minute. So sine theta cos theta minus cos theta sine theta cancel हो गया. अच्छा, what do we have? We have cos theta plus sine theta minus sine square theta minus cos square theta. Okay, so let's write this nicely. Cos theta plus sine theta. Then let's take the minus sign common. Okay, yeah, in fact, let's not skip a step. नहीं तो आप लोग परेशान हो जाएंगे. Minus sine square theta minus cos square theta. How many marks is this? It's a 3-mark question. And always have a look at the amount of space that you're given so that you can just utilize it efficiently. So 1 minus 2 sine square theta. Now keep your eyes on the price. If you notice, you have cos theta here, you have sine theta, and then you have minus 1. Now what's the connection? What is the connection between this 1 and this here? So once again, you have to be a few steps ahead, and you can think a little outside the box, that if you have something like minus sine square theta minus cos square theta, that's basically nothing but minus 1. Why? Because if you take minus common, so you have sine square theta plus cos square theta, which is equal to 1. There you go. So that means this is nothing but cos theta plus sine theta minus 1 over 1 minus 2 sine square theta. That's it. Job done. मज़ा आया? सर यूट्यूब पर भी अनाउंस करिएगा, पढ़ाई की वजह से इंस्टा उड़ा है. बहुत अच्छी बात है बेटा, आपने इंस्टा बिल्कुल मैं यूट्यूब पर डेफिनेटली अनाउंस करूँगा. I don't understand the first multiplication steps of the fractions. So we're taking the LCM. The LCM would be a result of multiplying these two. Okay, so now we multiply this with whatever it is we have to bring it equal to the LCM. And we multiply this with whatever we have to bring it equal to the LCM. That's it. ठीक हो गया, चलें आगे. Okay, now, I think this is perhaps the most difficult part of this paper. Sir, can the mock test? The mock test will be at night. It will be around 7 p.m. Okay, it will be around 7 p.m. inshallah. Using the results of A part 2 and B, solve the equation. Okay, using the result of what? Using the result of A part 2, which is basically this, and using the result of part B, which is what we have just done. We're supposed to solve this equation. Okay, now, let's see how we can solve this equation. So first of all, let's see what we have. Okay, so this is what we have. We know that this is equal to what? This is basically equal to cos theta plus sin theta minus 1 over 1 minus 2 sine square theta. Okay, we just figured that out, is equals to 2 cos theta plus sine theta minus 1. Okay, now अब देखो ये जो क्वेश्चन है ना इसमें okay, let me see how much space we have. ठीक है, so we will cancel. Okay, now notice that we can cancel this and we can cancel this, correct? We all can agree that we can cancel this and we can cancel this. But whenever you do that, there is a small problem with that. Okay, there is a small problem with that. Why? Because you lose a potential solution. And what's that solution that you lose? You lose equals to 0. ठीक है? So basically इसको अगर हम cancel करेंगे ना तो एक problem क्या है? एक problem ये है कि वो जो equals to 0 वाली चीज़ है will miss out on that. Okay, will you lose one solution? Exactly. Why is that? I'll explain. So for example, let's say you have x into x minus 2 equals to x. Okay, suppose this is what you have. If you cross out the x, then what happens? You have x minus 2 equals to 0, so that means x equals to 2. Okay, but what if you don't cross out the x? What if you don't cancel? Then notice what happens. X into x minus 2 is equal to x. X square minus 2x is equals to x, which means x square minus 2x. And then if I shift the x across the equals to sign, what happens is, actually, wait a minute. Sorry, wait a minute. It's not going to be equals to 0. It's going to be equal to 1. Okay, let me do it from the beginning, because this question mein catch hi hai ye. So suppose you have x into x minus 2, which is equal to x. Now, if you cancel, that means यहाँ पे क्या बचा? यहाँ पे बचा 1, because you've crossed out x, right? That means x minus 2 is equals to 1, which means x is equals to 3. Okay? But what if you don't cancel? If you have x into x minus 2, which is equal to x, if you don't cancel, notice what happens. You have x square minus 2x minus x equals to 0, which means x square minus 3x equals to 0. Now, if you take x common, so you have x minus 3 equals to 0, which means x equals to 0, or x minus 3 equals to 0, which means x equals to 3. Okay, so if you don't cancel, you get 2 solutions. If you cancel, you get 1 solution. Okay, so remember, whenever you cancel out a variable on both sides, that means you are losing out on a solution. Okay, you're losing out on a solution. So I repeat, if let's say you have x minus 2, x into x minus 2 equals to x, and if you cross out the x on both sides, okay, so x, say x cancel hua, that means यहाँ पे 1 बचा है, not 0. Okay, it's like you're dividing both sides by x, so you'll have 1 left over here. So this is what it simplifies to, and this is the solution that you get. If you don't cancel, okay, and if you expand it, and then if you solve, you get 2 solutions. One is 0 and the other is 3. ठीक है? अच्छा, अब इस क्वेश्चन को एक तरीका सॉल्व करने का ये भी है कि हम सारी टर्म्स लेफ्ट हैंड साइड पे ले जाएं एंड देन वी टेक कॉमन. ठीक है, सो आई डुप्लीकेट दिस बिकॉज अभी इसकी एग्जामिनर रिपोर्ट पढ़ते हैं. आई एम श्योर इसमें स्टूडेंट्स को ये प्रॉब्लम हुई होगी आइडेंटिफाई करने में. एंड आई थिंक दिस इज़ परहैप्स द ट्रिकीस्ट क्वेश्चन इन दिस एंटायर पेपर. सो एक काम करते हैं, लेट्स क्रॉस दिस, लेट्स शिफ्ट दिस अक्रॉस द इक्वल्स टू साइन. So this is what we have. We have cos theta plus sin theta minus 1 over 1 minus 2 sine square theta. Now there is another problem in this. The other problem in this, okay, the other problem in this is that you're not given enough space. ठीक है, so अगर space ज़्यादा होती तो मैं आप लोगों से कहता कि आप इसको इस तरह करें, but we don't even have a lot of space. So now what you can do is you can take cos theta plus sin theta minus 1 common, and if you do that, you have 1 upon 1 minus 2 sine square theta minus 2 equals to 0. And now you can see that you have cos theta plus sin theta minus 1 equals to 0, which means cos theta plus sin theta is equals to 1, and we already know the answer to this is 0. And what was the other answer? We don't have to solve this again. We already know the answer to this is 0 and half pi. ठीक है, ये हम already verify कर चुके हैं. 0 and half pi. ठीक है. The other would be 1 over 1 minus 2 sine square theta is equal to 2. Why? Because it's going to be equal to 0 equals to 2. So I've skipped a few steps. So that means 1 is equals to 2 minus 4 sine square theta. Okay, now let's solve this. So this would be 4 sine square theta is equals to 2 minus 1, which is equal to 1, which means sine square theta is equals to 1 upon 4, which means sine theta is equals to plus minus 1 upon 2. And then you can solve for sine theta equals to plus minus 1 upon 2. You will only solve for positive because negative will be outside the range. And when is sine theta equal to plus minus 1 upon 2? You can solve this using ASTC. I will drag this here so that we have some room. And sine is positive in the first and the second quadrant. Okay, so sine inverse of 1 upon 2 is pi upon 6. Yeah, pi upon 6, pi upon 6. And then the answers that we have is pi upon 6 and then pi minus pi upon 6. So that's 5 pi upon 6. So overall, the answers are 0, 1 upon 2 pi, pi upon 6 and 5 upon 6 pi. ठीक है, अब ये काफ़ी मुश्किल सवाल है. There are no two ways about it. There is no trick to it. There is no shortcut to it, sadly. You have to realize that you cannot cancel. And if you do cancel, remember you lose out on the solution, which is equal to 0. Okay, so no doubt it's a difficult question. Let's read the examiner report. I'm sure it probably says the exact same thing. Okay. In part C, many candidates seemed unsure of what was required and it was omitted by 20%. So that means 20% of the students completely left it. Okay. For those who did gain a credit, it was usually cancelling out after sine theta, cancelling sine theta plus cos theta minus 1 rather than taking this out as a common factor. So if you do cancel, the problem is that you will forget that there is a factor that you're missing out on. Okay, that is sine theta plus cos theta minus 1 equals to 0. This usually led to only 2 of the correct solutions. A few responses only considered sine theta plus cos theta minus 1 equals to 0. When cancelled, obtained 0 rather than 1. To get full marks, 4 correct answers were required. Okay, so I'll go over this again. Achha, first of all, why can you not cross multiply? Because the question says that you have to use the result. If you cross multiply, then you will probably make this a nightmare for yourself because we already know that this, okay, is the same identity as the one here, which can be written like this. Okay, so that's the answer to that question. Achha. When you rewrite it like this, you may be tempted to cancel. Okay, and there's nothing wrong in cancelling, but when you cancel, remember, it's because cos theta plus sin theta minus 1 could be equal to 0. Okay, so अगर आप cancel कर रहे हो तो ये याद रखो. और cancel करने में problem क्या है वो मैंने यहाँ पे identify कर दिया. ठीक है, a better way would be to move all the terms to the left hand side and then take this common. Okay, if you then take this common, you will know that it's either this equal to 0 or this equal to 0. Okay, like a quadratic equation. So of this equation, we already have the solutions from A part 2, which is why the question is asking us to use the answer from A part 2, and that's basically right here. 0 and pi upon 2, okay? Achha. Then, for this equation, we solved like a normal trigonometric equation, okay, by using ASTC. So first we made sine squared theta the subject, sine theta equals to plus minus 1 upon 2, and then we solved, like I said, the way that we do it normally, okay? So a tricky question, there are no two ways about it, but it is what it is. All right, now question number 8. The diagram shows the graph y is equals to f of x where the function f is defined by so and so. On the diagram above, sketch the graph of y is equals to f inverse of x. Okay, so easy. What we have to do is we have to reflect. Okay, we have to reflect. And we have to reflect it along the line y equals to x. So do that smartly. First of all, draw the line y equals to x. So that line we know is going to be a line that is passing from the origin and every y value is equal to the x value. So this is the line y equals to x. Okay, so mark 2 3 points and then join the 2 3 points and you will have your straight line. There you go. This is the line y equals to y equals to x. Okay. Then after that, we're supposed to reflect. Now if you look at this point, here you can see that the x coordinate is 0 and the y coordinate is just a little less than pi. So that means once we reflect it, it's probably going to end up somewhere over here. Okay, so once we reflect it, it's probably going to end up somewhere over here. Then let's take some other point. Let's take some other nice point. And that is perhaps this one. So this point is almost in between pi and 3 upon 2. and in between 3 upon 2 pi. Or you can just reflect it from here, that it's probably going to be somewhere over here once you reflect it. And then there is a point that's on the line of reflection. That's the invariant point. So it's going to be common for f of x and the inverse function as well. So there you go. This is what the inverse graph looks like. That's it. Let's fix this slightly. And just make sure that your graph looks like the inverse, looks like the mirror image of the graph that's already drawn. Acha, you don't have to do that. I don't suggest that you, because you're going to have you're going to have a lot of difficulty identifying what value is equal to what, because every value on the x and y axis is in terms of y, so you're going to have a lot of difficulty identifying which value is equal to what. Okay? So I don't recommend that you do that. Acha, do we need to draw the line y equals to x? Not really, but it's for your own good, so that when you walk away from it, you make sure that it looks like the mirror image. Okay, so let's read the examiner report. The response to this question was varied with many fully correct solutions, but also many responses scoring few or no marks at all. In part A, many candidates seemed to know reflection along the line y equals to x was required, but often they assumed that this line could be plotted by joining the origin to the top in point, to the point in the top right hand corner. Okay, so here's what they did. They assumed that this is the line y equals to x. That's not the case. Okay, so keep your eyes and ears open. Look at the x and y values. So a point where x is equal to y, that is basically a point that with the line y equals to x will pass through. Okay. On the diagram, sketch the graph of f inverse of x. Find the expression for f inverse of x. Okay, so we know that there's a pretty standard way of doing that. Y is equals to 3 plus sine 1/4 of x. So we make x the subject. Okay. In the previous question, why did we ignore sine minus half? We ignored sine minus half. That's because minus would be in the third and the fourth quadrant, and that is outside the range. So Hamad, please read the question carefully. So we're going to make x the subject. So sine 1 upon 4x is equals to y minus 3. What do? We take sine inverse. So sine inverse of y minus 3. Then we make x the subject. So x is equals to 4 sine inverse of y minus 3, and then the final step, which is we replace x with f inverse of x, 4 sine inverse x minus 3. It's 2. Oops. Forgot the 2. 2 upon 2 upon 2 upon 2. Yes, I do have a live stream for just domain and range also. Okay, there you go. Thank you for pointing that out. Who was that? Muzammil. Thank you. Appreciate it. Now. Okay, let's carry on. The diagram shows part of the graph of the function g of x is equals to 3 plus 2 sine 1 upon 4x for minus 2 pi to 2 pi. Complete the sketch of the graph g of x on the diagram above, and hence explain whether function g has an inverse or not. Okay. So let's see. Let's start plugging in values. So let's plug in minus half pi. Okay, so I'll use my calculator here. Now this is an easy question, but they've tried to make it difficult. Okay. This is an easy question, but they've tried to make it difficult. How? How do you think they've made an easy question difficult? Question for you guys. A fairly easy question, which they were like, okay, here's an easy question. They probably sat down and then they asked that how can we make this question difficult? Tell your mind that's going to be yeah, exactly. They said pi on y-axis. Okay. So I'm pretty sure that's what the thought process was. So they would be like, no, wait a minute. We don't want to make this too easy. Let's see how we can make this difficult. So some genius probably came up with the idea that, you know what, how about we give the values on the y-axis in terms of pi? And then that person probably got a promotion. Now, that is what makes this question difficult. Other than that, it's a piece of cake, honestly. Okay. So we're going to plug in these x values that we're given one by one. Okay. And we're going to find out what they're equal to. And that's it. We're just going to mark them. But here's the thing. Here's my suggestion. Before you do that, ठीक है, और let's say हम इसको एग्जाम में सॉल्व करें, ठीक है. इन हाइंडसाइट तो we know what to do, right? But if you're doing this in the exam, let's see what happens. So 3 plus 2 sine, make a fraction, right? 1 upon 4, make a bracket, and then write minus pi upon 2. Okay, so in the bracket, I'm going to write minus 1 upon 2 pi. So minus here, 1 upon 2 along with pi. Close the bracket. There you go. Now, we have run into a problem. Okay. The problem is, while we do know exactly what it's equal to, but the question is, where do I mark this? I know that the x coordinate is this, but the question is, where do I mark this? उसके लिए मेरा आपको मशवरा ये है कि आप एक काम ये करें, इस वैल्यू को थोड़ी देर के लिए we will write it on the side. So this is 2.2346. Okay, so I've written it on the side. Now what I'm going to do is, I'm just going to find out these values, okay, in decimal. I'm going to write them down. So this is in between pi upon 2 and 0. So that means this is probably pi upon 4. So let's work that out. Let's see what pi upon 4 is. That's equal to 0.785. तो मैं यहाँ पे approximately लिख लेता हूँ. And let's see what is pi upon 2. Pi upon 2 is 1.57. Okay, and then we all know pi is equals to 3.14. I hope you guys all know. And then what about in between? So in between, that's going to be, so what's in between half and 1? That's 3 upon 4. So let's work that out. So 3 pi divided by 4. That's equal to 2.356. Okay. Acha, if you use the table feature, okay, if you use the table function, you're going to run into the same problem. You wouldn't know where to mark it. Okay. You wouldn't know where to mark it. That's why you can use the table feature, but it's not really a game changer. Okay, now let's go back. So this is what we got. We know that at minus pi upon 2, it's 2.23 something. That means 2.23 is going to be just below, slightly below this point. Okay. Now let's see what is the value at minus pi. So now I'm going to change this to minus pi. So I'll simply write this as minus 1 upon 1 pi because I don't want to lose the fraction. So that's equal to 1.5857. So that means as good as 1.57. So I'm going to mark it slightly above it. Okay. And then let's write minus 3 upon 2 pi. So what's minus 3 upon 2 pi? Minus 3 upon 2 pi. So minus 3 upon 2 pi is 1.15. Now 1.15 will be somewhere in between these two values, 0.7 and 1.57. So probably somewhere over here. Okay. Acha. Then let's write minus 2 pi. So minus 2 pi, we can get rid of the fraction now. We don't need it anymore. So minus 2 pi is equal to 1. Now where do I mark 1? I mark 1 slightly above 0.7, but below the point that I've just marked. Okay. Now here we have, that's it. Now, I mean, that's not it. That was quite a lot actually, but there you go. This is how you're supposed to do it. Achha, ab dekho, for those of you who are saying ke, why can't we use the table feature of your calculator? Ab dekho. Here's the thing. If you use the table feature, then this is the problem that I have with the table feature. It's not going to help. तो अभी जितने लोग स्मार्ट बन रहे हैं और कह रहे हैं कि हम टेबल फीचर यूज़ कर लेते हैं, काम आसान हो जाएगा, अभी पता चल जाएगा टेबल फीचर क्यों नहीं यूज़ कर सकते. So 1 upon 4x, close the bracket. Okay. g of x को skip करते हैं. Let's start from minus 2 pi. Okay. Let's end it at 2 pi. ठीक है. And in between, the step that we have taken is basically pi upon 2. Okay. So pi divided by 2. The problem that I have with the table feature is that, I just realized that minus 2 pi was actually here, not there. Yeah, now it's correct. Okay, so the problem that I have with this table feature is this. Okay, the problem that I have with the table feature is this, that here you see values in terms of pi, here you see them in decimal. So it's very easy to not round it off correctly. Okay, or it's very easy to basically not realize which value is which. Now here we know that minus 6 is minus 2 pi, लेकिन अब ये हो सकता है कोई mess up कर दे. Because here you see values in a different unit, here you see them differently. So that's the issue that I have with the table feature. If the values of x, or if angle is in radian. If it's in degrees, then no problem. I fixed it. I fixed the last coordinate. Okay. I fixed the last coordinate. अच्छा Osman, I appreciate कि आपने बता दिया. Because I'm definitely going to hide you now. Okay. Value, what's that? Won't step be 0.25 pi? देखो, my advice is कितनी values हैं बेटा? कितनी values हैं? 1, 2, 3, 4. 4 values हैं. 4 values में आप table feature use करके आप क्या कमाल कर लेंगे? ठीक है? तो बेहतर है आप manually plug in कर लें ताकि ये debate ही नहीं रहा whether we use pi upon 4, whether we use pi upon 2. Simple as that. Okay? Now, complete the sketch. So we've done that. So what do you think? This will have an inverse? What do you guys think? You think this function, this graph will have an inverse? Yes or no? And I want a logical explanation as well. Do we say yes or no? And if we're saying yes, why are we saying yes? Yes, it does. Why? Because it's a one-to-one function. Okay? Acha, just a minute. Just a minute. I want you guys to look at the following part and tell me, okay, what's the answer? Okay, now, so describe fully a sequence of 3 transformations which can be combined to transform the graph y is equals to sine x to so and so, y equals to f of x. Achha, it will have a function because it's a, it will have an inverse because it's a one-to-one function. Achha, why is this a one-to-one function? Why is this a one-to-one function? It's a one-to-one function because it passes the horizontal line test. Simple as that. Okay? So we can do this without finding out values in decimals. अगर आप पूछ रही हैं तो no, but अगर आप बता रही हैं तो please tell us how. Okay, so describe fully a sequence of 3 transformations which can be combined to transform the curve. Okay. So what are the 3 transformations? Let's have a look. First, let's write them nicely. So, let's write it nicely. Y is equals to 2 sine 1 upon 4x plus 3. Okay, so this is the end product. What was the starting point? The starting point was this. Y is equals to sine x. Okay. So first of all, let's multiply sine 1 upon 4x by 2. Okay, so the very first transformation is that it's a stretch parallel to y-axis, or you can say vertical stretch. It's a stretch parallel to y-axis, and the scale factor is equals to 2. Okay, and you know what you can do? You can do this on the side also. So if let's say you have y equals to sine x and you apply the first transformation, y is equals to 2 sine x is what you end up with. Okay. Now transformation number 2. Transformation number 2 is that we now have to stretch it parallel to the horizontal axis, okay, parallel to the x-axis. So transformation number 2 is that it's a stretch parallel to x-axis. But here's the question, what will be the scale factor, or stretch factor, sorry. Stretch factor or scale factor? What do you think? In the meantime, I will write down the third and the easiest translation. Beta, it's the same. Okay, f of x or g of x don't same. Scale factor 4, that's correct. So scale factor will be equal to 4. Because it's 1 upon 4, so that means the scale factor is basically 1 over 1 upon 4, which means it's equal to 4. Now then we have translation. translation would be 0, 3. Acha. Now the question is, what are the possible orders of this? Okay, so how many orders can we write the answer in and still get the right answer? Okay, so the answer to that is that you can basically change this and this. No, wait a minute. You can change this and this, but as far as translation is concerned, translation must come after stretch. Why? Because remember, if you have multiple vertical translations, you follow BODMAS. Okay, so if you have multiple vertical translations, what you do is you basically follow BODMAS. Okay, so you can change the order of 1 and 2, but whatever you do, the translation must come after the stretch. Okay, so you can change this also. You can change the order of 2 and 3, but the translation must come after the stretch. Okay, so whenever you have multiple vertical transformations, you follow BODMAS. Whenever you have multiple horizontal transformations, what you do is you follow opposite of BODMAS. Okay. Now I have a stream on transformation. In fact, I've done 2 streams on transformation, and I've done one in previously also. Okay, so I would suggest you guys watch that to understand how it's done. Okay. Now let's do APGP. The second term of a geometric progression is 16, and the sum to infinity is 100. Find the 2 possible values of the first term. Okay. So Feb March 2025 paper काफी है for prep. Depends on what you're preparing for. So the second term of a geometric progression is 16. So that means AR is equals to 16. And the sum to infinity is equal to 100. Sum to infinity means A over 1 minus R is equals to 100. So we have 2 unknowns. We want 2 equations. And we have just that. Here's the first equation. Here is the second equation right here. Now, what are we supposed to find? We're supposed to find the 2 possible values of the first term. So we're going to make R the subject so that we have an equation for A. So R is equals to 16 upon A. Now let's plug in this here. So A over 1 minus 16 upon A is equals to 100. Now let's cross multiply. So we have A, which is equal to 100 minus 1600 upon A. Okay. Now let's cross multiply, see what we end up with. Or let's take the LCM. So, okay, so we have plenty of space. So A is equals to 100A minus 1600. Now let's cross multiply. So that's A square is equals to 100A minus 1600. Now let's move all the terms to the left hand side. A square minus 100A plus 1600 is equals to 0. So we're looking for factors of 1600 that give you 100. So that's 80 and 20. So now let's do middle term breaking. A square minus 80A minus 20A plus 1600 is equals to 0. Let's take A common. So that's A minus 80 minus 20 common le lete hain. So that's also A minus 80, which is equal to 0. So A is equals to 20 or A is equals to 80. There you go. Okay, so we have the answer to the first part, 3 easy marks. Now part B. Part B says, show that the nth term, now this is a difficult question. Okay, this is definitely a difficult question. Isko karne ke liye na, kafi sare, I mean, a lot of students I think got this wrong. Okay, and the question is a little bit ambiguous. There's no doubt about that. The question is a little bit ambiguous, but the good news is that even if you don't get it exactly right in the first attempt, you can still somehow get it right, given that you don't make a sign error or something like that. Okay. Now, let's see what the question says. Show that the nth term of one of the 2 possible geometric progression is equal to 4n minus 2 multiplied by the nth term of the other geometric progression. Now, here's the thing. What's the nth term of the geometric progression? So the nth term of one geometric progression, remember A is equals to what? A is equals to 20. Okay. So A की एक वैल्यू हमने 20 निकाली है, A की एक वैल्यू हमने 80 निकाली है. ठीक है. So अब एक काम करते हैं. Let's find out the value of R. Okay, so let's take the value of a as 80. So in that case, what's r equal to? R is equals to 16 upon a. So 16 upon a means 16 upon 80. So r is equals to 1 upon 5. Okay, so that means one geometric progression is ar raised, since the general term is ar raised to the power n minus 1. So that means it's 80 multiplied by 1 upon 5 raised to the power n minus 1. Okay. Now, when we worked out a to be equal to 20, and by the way, make sure that this working you show here because it's relevant for this part. Okay, and I'll do it here. So if a is equals to 20, r would be equal to 16 upon 20, which means it's equal to 4 upon 5. So that means the other general term that the question's talking about is basically 20 into 4 upon 5 raised to the power n minus 1. Okay. Now here's the thing. According to the question, show that the nth term of one of the two possible geometric progressions. Now the confusion is that which one should we multiply? Okay. So the question says is equal to 4n raised to the power minus 2 multiplied by the nth term of the other geometric progression. Okay, so let's take a guess. Let's take 80 multiplied by 1 upon 5 raised to the power n minus 1. Let's multiply this by 4 raised to the power n minus 2. And let's see if this is equal to 20 raised to the 20 into 4 upon 5 raised to the power n minus 1. Okay. Now here's what we're going to do. Pay close attention. We're going to keep this as it is. Okay. And we're going to shift this across the equals to sign. Okay. And we're going to simplify to see if it actually simplifies to 4 raised to the power n minus 2. ठीक है, तो क्या करेंगे हम? Pay close attention. So हम 4 raised to the power n minus 2 को ऐसे ही रखेंगे. ठीक है. और हम इसको shift कर देंगे across the equals to sign to see if these two actually simplify and give us 4 raised to the power n minus 2 or not. Okay. Now, how much space do we have? We have plenty of space. So first of all, what's 20 upon 80? That's equal to 1 upon 4. Okay. Now, what do we multiply this with? So notice that we have two bases that have the same powers. Okay, so what can we do about the bases? The bases can be divided. Remember rule of indices that if you have a power m divided by b power m, that means a and b can be divided and both of them can be raised to a common power. Okay. All right, so I'll explain it again. So basically, according to the question, you take the nth term of one geometric progression multiplied by 4 raised to the power n minus 2 and show that it's equal to the nth term of the other geometric progression. Now, there's no point in simplifying this. It's going to take us forever because there's no way that you can simplify this and bring it equal to this. I mean, you can, but it's going to be difficult. So how about, what is it that can be simplified? So instead of multiplying the two, we'll leave this as it is. We'll take this across the equals to sign. Since it's being multiplied here, that means if you take it across, it will get divided. Okay. So now here we are dividing. So first thing we've done is we've simplified 20 and 80. Now let's simplify 4 upon 5 divided by 1 upon 5. Now what's 4 upon 5 divided by 1 upon 5? That's 4 upon 5 into 5, which means 5 and 5 cancel. And we have 4 raised to the power n minus 1. Now we're almost there yet. I mean, we're not there yet, but we're almost there. So this can be written as 4 raised to the power minus 1. This can be written as 4 raised to the power n minus 1. Same basis can be multiplied. Okay. And this becomes 4 raised to the power n minus 1, which means 4 raised to the power n minus 2. ठीक है. अब let's say अगर आपने उल्टा कर दिया होता. I know a lot of you at this point might ask, and it's a very legit question, that how do we know that we have to multiply this general term by this? ठीक है, अगर आपने उल्टा कर दिया, let's say if you multiply this general term by 4 raised to the power n minus 2 to show that it's equal to this. So if you do that, then your answer should be the opposite of what we've ended up with. Okay, your answer should not be 4 raised to the power n minus 2. Your answer should be the opposite of this, meaning your answer should be 4 raised to the power 2 minus n. Okay, and that's still also perfectly all right. That's still also perfectly all right. Okay, so it takes a bit of it takes a lot of confidence to get this question right, because halfway through a lot of students will probably stop doubting what they're doing. So I think the differentiating factor between getting this, a student who gets this question right and a student who doesn't, is the confidence. Now let's go over the examiner report and see what it says. In part B, candidates not seem to recognize the answer from part A were meant to be used. Many who were able to form the nth terms were unable to go on to prove the given statement. For those who were successful, often divided the nth term, separated this successfully. Incorrect statements such as this were common. Okay, now. Achha, how many questions do we have? We have 2 more questions, so let's speed things up. Question number 10. Question 10 says, the equation of a circle so-and-so and the line y equals to half x plus 6 is a tangent to the circle at the point P. Show that one possible value of a is 4 and find the other possible value. I think I solved this question yesterday. ठीक है, तो आप लोग कल वाली stream देख सकते हैं. I'm not going to do this question again. It's going to be a total waste of time. But I will walk you guys through the solution of this question. मैंने इसको कहाँ solve किया था? कल मैं जब circles की stream कर रहा था, तो I solved this. Here. So I'll just you guys can watch the yesterday's stream for the solution. I'll just copy paste it in the meantime. I'll just walk you guys through the solution. So basically, the concept of discriminant can be applied to not just a curve and a straight line. It can be applied to a straight line and a circle as well. Okay, so take the equation of the straight line, plug it into the equation of the circle. Okay, expand. You will have a quadratic equation. Since it says tangent, b square minus 4ac is equal to 0. Solve that, you will have the other value. You will have 2 values of a. One is 4, the other is minus 16. The question says that one is a. You're supposed to find the other possible value. And you're supposed to do that by solving it through middle term breaking. And that's minus 16. Okay, now this part C was a really difficult question. And I do encourage you guys to watch yesterday's stream to solve this, to learn how this is solved. And it was perhaps the most difficult question in this paper. Okay, although वैसे तो पूरा paper ही honestly difficult है, but part C इसका काफ़ी difficult था. So I do encourage you guys to watch yesterday's stream on equation of circles. I think it was the last question that I did to see how it was done. Okay, now let's do this. So O-level वाले बच्चों का mock P1, it's P1 non-calculator. Now, the equation of a curve is so-and-so, find dy by dx, and we're told that k is a positive constant. So maybe later on we'll have the value of k, which we're supposed to find, and we're supposed to keep in mind that it's positive. No, you don't use product rule in P1. Okay, k is a constant, so you don't have to use product rule. So what you do is you write it nicely, and even if, let's say, you can use product rule in P1 if you've done P3, okay, but you will never come across a question in P1 where you have to use product rule. So dy by dx will be equal to k times half, that's half k. 4x plus 1, we take 1 away from the power, so that's minus half, minus 1 plus 0. So let's write this nicely, although the question doesn't say anything, because you're supposed to write it in a certain way or something. Also don't forget that you're supposed to multiply it by the differential of the bracket, which is 4. I always forget to do that. Make sure it doesn't happen to you guys. So 2k upon square root of 4x plus 1, so I've made it positive, minus 1. There you go. Sir, please tell when integrating we have form a plus b whole square should be open. It's best that so if inside the bracket you have a linear expression, then there's no need to open. You can use the power rule. Okay, find the x coordinate of the stationary point in terms of k. So how do you find out the x coordinate? You take dy by dx and you equate it to 0. Simple as that. So this is equal to 0. So that means 2k. Now notice that in between, there were a lot of questions that were difficult in between. Now in the end, we have a fairly easy question. Okay, in the end, we have a fairly easy question. So we're supposed to find out the value of x. So step by step, let's make x the subject. So 4x plus 1 is equals to 2k. Now let's square both sides to get rid of the square root. So 4x plus 1 is equals to 4k squared. 4x is equals to 4k squared minus 1, which means x is equals to 4k squared minus 1 upon 4. There you go. That's the answer. Okay, given that k is equals to 10.5, find the equation of the normal to the curve at the point where the tangent to the curve makes an angle of tan inverse of 2 with the positive x-axis. Okay, so I think I've solved this question maybe in a live stream or something, but I don't remember if I have. I'm not too sure. So I'll just do it again. So ये एक मजे का सवाल है. So basically, a good idea would be 2x squared plus 3 wholes. Yeah, in that case, you open. So a good idea would be to make a rough sketch. So this is a curve. So just make any random curve. You don't have to get it exactly right. Okay. And there's a tangent. Now the tangent is basically at a point where, not the point where the tangent makes the angle that you're given, but the tangent is drawn such that when you extend it, this tangent makes an angle which is theta. And what's theta equal to? Theta is basically equal to tan inverse of 2. Now remember, if I take tan across, so tan theta is equals to 2. Now we've gone over this, that tan theta, what is tan theta? Tan theta is basically opposite upon adjacent. So opposite upon adjacent is what? Opposite upon adjacent is basically the same as the gradient. So opposite upon adjacent. So tan theta is opposite upon adjacent. And what's opposite upon adjacent? That's basically change in y upon change in x. So that means 2 जो आप देख रहे हैं, ये basically क्या है? ये basically dy by dx है. So that means there is a point on the curve where dy by dx is equals to 2, and you're given the value of k, which is 10.5. So what we're going to do is, we are going to use dy by dx. Okay. We're going to set it equal to 2, and we're going to plug in k as 10.5. So this is equal to 2, and k is basically equal to 10.5. ठीक है. So confirm कर लेते हैं 2k ही था ना? हाँ 2k था. Okay. So 10.5 times 2, that's 22 over square root of 4x plus 1, which is equal to 3. Now let's solve this. Yeah, this is definitely a good question. Sorry, that's 21, not 22. 21. Okay, so 3 1s are, 3 7s are. Now square root of 4x plus 1 is equals to 7. Let's square both sides so that we can get rid of the square root. So 4x plus 1 is equals to 49. X is equals to 50 upon 4. That's equal to 12.5. Achha, the story doesn't end there. Okay, the story doesn't end there. 50 divided by 4, let me confirm that. Yeah, that's 12.5. The story doesn't end there. Now we're supposed to basically find out the corresponding y coordinate. Okay, how will you find out the corresponding y coordinate? By plugging in the value of x into the equation of the curve. So x is 12.5. Let's plug this value of x back into the equation of the curve, because what do we have to find out? We have to find out the equation of normal. Okay, we have to find out the equation of normal. Oh yeah, it's 48 upon 4. I did 50 upon 4, sorry. So x is equals to 12. ठीक है, thank you for pointing that out. अच्छा जी. So let's find out the y value. Now that's going to be 10.5 into square root 4x plus 1, so 4 into 12 plus 1 minus 12 plus 5. So the y value is 66.5. Okay, achha, now be careful. This was the gradient of tangent. Okay, we want the equation of normal. So that means the equation of normal, if you're finding out the equation of normal, the gradient of normal will be minus 1 upon 2. Okay, so let's use this information. Y minus 66.5 is equals to minus 1 upon 2 into x minus 12. Let's see if the question wants us to write it in a certain form. No, it doesn't. So that means this is good enough. You can leave it here, and that's good enough. ठीक हो गया? मजा आया? Sir, ये change in y over change in x क्यों लिखा है? Because tan theta is basically equal to the gradient. Okay, tan theta is basically equal to the gradient. Why? Because it's opposite upon adjacent. Okay, it's equal. Remember, it's equal to the gradient because it's opposite upon adjacent. Okay, and what's opposite upon adjacent? Opposite is change in y, adjacent is change in x. Okay, so I'm going to stop here. Equation of circle. अच्छा, इस question का अगर आपने solution देखना है, तो आप लोग एक काम ही कीजिएगा, मेरी कल वाली स्ट्रीम देख लीजिएगा in which I've solved this question. I don't remember whether this was the last question or I solved it somewhere in between, but you can check it out from the last stream. Okay, I didn't do it again because it was a very annoyingly lengthy question. वो use होता है if you're supposed to find out the angle between two lines. Ali, you will find that question in my, you'll find that in my notes. I don't know if there's an example question which I've done in my notes, but you will find out. You will find out. क्या मिलेगा आपको? You'll find the concept in my notes. ठीक है, अच्छा, here you go. This is the answer to part C. ठीक है, मैंने last class में इसका एक short method भी बताया था, so make sure to check that out also. What is the probability of repeated questions? I don't know. I'm no one to say that. Nobody is in a position to figure that out. But I will encourage you guys to not listen to anyone. Just focus on your own preparation. Simple as that. Okay? Achha, I'm going to stop here. I would really appreciate last stream that I did yesterday on equation of circles. Make sure to check it out, in which I've solved this question. Okay? Now I'll stop here. I'll see you guys inshallah in the next stream. Take care everyone. Jate jate, if you haven't liked the stream, I would appreciate if you do that. And also make sure to subscribe to the channel if you haven't done that yet. Okay? So take care everyone. Keep solving past papers. Make the most of the time that you have left. See you guys in the next one. Take care fellas. Allah Hafiz. Next stream I'll announce on my Instagram. Okay? I'll announce on my Instagram whenever I'm having the next stream inshallah.